creating a virtual version of something, including virtual computer, as a method of logically dividing the system resources provided by mainframe computers between different applications. Since then, the meaning of the term has broadened. Hardware virtualization or platform virtualization refers to the creation of a virtual machine that acts like a real computer within an operating system. Software executed on these virtual machines is separated from the underlying hardware resources. For example, a computer that is running Microsoft Windows may host a virtual machine that looks like a computer with Ubuntu Linux operating system. Ubuntu-based software can run on the virtual machine. In hardware virtualization, the host machine is the machine which is used by the virtualization, and the guest machine is the virtual machine. The words host and guest are used to distinguish the software that runs on the physical machine from the software that runs on the virtual machine. The software or firmware that creates a virtual machine on the host hardware is called a hypervisor or virtual machine monitor. Different types of hardware virtualization include full virtualization, almost complete simulation of the actual hardware to allow software environments, including a guest operating system and its apps, to run unmodified. Para-virtualization: the guest apps are executed in their own isolated domains as if they are running on a separate system, but a hardware environment is not simulated. Guest programs need to be specifically modified to run in this environment. Okay. Hardware-assisted virtualization is a way of improving overall efficiency of virtualization. It involves CPUs that provide support for virtualization in hardware and other hardware components that help improve the performance of a guest environment. Hardware virtualization can be viewed as a part of an overall trend in enterprise IT that includes automatic computing, a scenario in which the IT environment will be able to manage itself based on a perceived activity, and utility computing, in which computer processing power is seen as a utility that clients can pay for only as needed. The usual goal of virtualization is to centralize administrative tasks while improving scalability and overall hardware resource utilization. With virtualization, several operating systems can be run in parallel on a single central processing unit (CPU). The Parallelism Trend suitor hardware platforms, storage devices, and computer network resources. Virtualization began in the 1960s to reduce overhead costs and differs from multitasking, which involves running several programs on the same OS. Using virtualization, an enterprise can better manage updates and rapid changes to the operating system and applications without disrupting the user. Ultimately, virtualization dramatically improves the efficiency and availability of resources and applications in an organization. Instead of relying on the old model of one server, one application that leads to underutilized resources, virtual resources are dynamically applied to meet business needs without any excess fat conscious tech. Hardware virtualization is not the same as hardware emulation. In hardware emulation, a piece of hardware imitates another, while hardware virtualization, a hypervisor, a piece of software, imitates a particular piece of computer hardware or the entire computer. Furthermore, a hypervisor is not the same as an emulator. Both computer programs that imitate hardware, but their domain of use in language differs. Snapshots. A snapshot is a state of a virtual machine that, and it generally storage devices at an exact point in time. A snapshot enables the virtual machine's state at the time of the snapshot to be restored later, effectively undoing any changes that occurred afterwards. This capability is useful as a backup technique. For example, prior to performing a risky operation, virtual machines frequently use virtual disks for their storage. In a very simple example, a 10 gigabyte hard disk drive is simulated with a 10 gigabyte flash file. Any requests by the VM for a location on its physical disks are transparently translated into an operation on the corresponding file. Once once such a translation layer is present, however, it is possible to intercept the operations and send them to different files depending on various criteria. Every time a snapshot is taken, a new file is created and used as an overlay for its predecessors. New data is written to the topmost overlay. Reading existing data, however, needs the overlay hierarchy to be scanned, resulting in accessing the most recent version. Thus, the entire stack of snapshots is virtually on a single coherent disk. In that sense, creating snapshots works similarly to the incremental backup technique. Other components of a virtual machine can also be included in a snapshot, such as the contents of its random access memory (RAM), BIOS settings or its configuration settings. Save state feature in video game console emulators is an example of such snapshots. Restoring a snapshot consists of discarding or disregarding all overlay layers that are added after that snapshot and directing all the new changes to the new overlay. So I'm going to leave it there for today. I hope you like this video, so please like, share and subscribe. Thank you.